Okay. All right. In this lesson, we are going to go over the three methods of sexagesimal multiplication. The first of those methods is called leveling, and the method involves converting both of the numbers involved in the multiplication to decimal and using the lowest order they have and multiplying the results in decimal and then converting everything back to sexagesimal. So we'll see how that works by an example again. So let's say we want to multiply these two numbers. Okay, so the numbers are 25 degrees and 42 minutes by 18 degrees and 36 minutes. Okay, so the lowest for each of these numbers is minutes. So what we are going to do is we are going to convert 35 degrees and 42 minutes into all minutes. Well, how do we do that? Well, that's not hard. Knowing that 1 degree is 60 minutes, so if we multiply 25 by 60, so that will convert 25 to minutes, and then add 42 to it, and the result is going to be 1542 minutes. So similarly, 18 degrees and 36 minutes will be 18 times 60 minutes plus 36 minutes, which equals 1116 minutes. So what you do next is go ahead and multiply these two numbers in decimal, using the decimal multiplication. So I'm not going to go over that, but just write the result here. So if you multiply these two numbers, the result is 1,722,872. Now the question is, what is the units of this number? Now what happens if you multiply minutes by minutes? Well, it should be, you need to remember the rules of exponents here. So minutes is really 1 over 60, right? Or 60 to the power negative 1. If you multiply that with 1 over 60, the result is 1 over 60 to the power 2, and this means seconds. Okay, so when you multiply these two numbers, the result is this many seconds. Now we want to go back and write this in a proper sexagesimal number, in terms of seconds, minutes, and degrees and so forth, where each digit is less than 60. So how do you do that? Well, doing that will be opposite of what we did over here. We converted everything to the lowest order term. So we did multiplication. Now we are going to do division to convert back to sexagesimal. So what exactly we do is this. We first take this number 1,720,872. So divide it by 60 and find the quotient and the remainder. So if you do that, it turns out that the quotient is 28,681, and then the remainder is 12. So this remainder is the correct number of seconds when this number is written as a proper sexagesimal number. So next, we take this quotient, which is a number greater than 60. You see, this means that this many seconds is 60 times this many minutes plus this many seconds. So this many minutes, it is too many minutes. It includes in it some degrees and properly some higher order digits as well. So we need to go and write this as a proper sexagesimal number. And to do that, we'll do the same thing. We'll divide this by 60 and find the quotient and the remainder. So it turns out that the quotient is 478 and the remainder is 1. Now, how do you do this division? Well, this is just the division in decimal that we already learned. Okay, so we are not giving the details of that. So here, the remainder is the same unit as the number that we started with, but the quotient is 1 unit higher or 1 order higher, which is, what is this? If you go 1 order higher from minutes, you get degrees, right? So this is degrees, and again, still this number is greater than 60, so we need to write it in terms of using higher order positions in sexagesimal. And to do that, we again divide by 60, and the result, now the quotient is going to be 7 and the remainder will be 58. And this is in degrees, and this is now the first elevates. Remember, this is the symbol I use for the first elevates. Whether it is a universal convention or not, I'll use that. Now at this point we can actually stop because the quotient obtained is smaller than 60. So this process stops when the quotient obtained is less than 60. So therefore, this big number here, all in seconds, when it is written as a proper sexagesimal number, the result is this. It is 7 first elevates, and then 58 degrees, and then 1 minute and 12 seconds. Okay, so this is the result of this multiplication as a sexagesimal number, a properly written sexagesimal number. So that was the first method. The second method is using a multiplication table. Okay. So to be able to use this method, you first need to have a multiplication table available, and we learned from the book that such tables are made in medieval times, and we have a portion of that table in the book on page 45, but it is, of course, it is all in Arabic. So so assuming that you know how to read such a table and one is available, so let's illustrate the procedure. And we are actually going to use the same two numbers to illustrate this method. Again, the numbers were 18 degrees 36 minutes multiplied by 25 degrees and 42 minutes. So in this method, we remember that we are going to remember the distributive property of multiplication over addition, and we can of course regard this number as 18 degrees plus 36 minutes multiplied with 25 degrees plus 42 minutes, and then we can apply the distributive property like this, right? Okay, so this is what is going to happen in this procedure. So as an addition, this will be done in 3 columns, and the middle column will accumulate the answer, and at the very end it will contain the answer. Okay, the first step is to take 18 and multiply it with 25, and then with 42, and then we do the same with 36. So very first step is to multiply 18 times 25, and this is where you use a multiplication table. You know, if you multiply these two numbers, it is 450. But again, this is not a proper way of writing in sexagesimal. You know, you can see that 450 is equal to 7 times 60 plus 30. So therefore, the two digits that you need to represent 450 in sexagesimal are 30 and 7. Remember, 30 is a single digit in sexagesimal. So therefore, what we are going to have after the first step is, okay, so here we are multiplying degrees times degrees. The result is at least degrees, but possibly higher. So in this case, since the result is greater than 60, we are going to need the higher digit. So here the smaller order digit is 30, and the higher order digit is 7. So 30 is in degrees and 7 is the first elevates, all right? And the rest of the table does not change. So 18 is here, 25 is here, 42 and 36. Okay, the next step is to multiply 18 and 42. And again, using a multiplication table. So if you multiply these two, you get 756. And to see the representation in sexagesimal, you divide it by 60, and you obtain the digits of 36 and 12. So these are the two digits that are needed to represent 756. So then what we are going to do, what we are going to have is, so 36 will go here and 12 will go to this position, and that means that we are going to add 12 to 30. So then what we are going to have is, so we'll have 36 here, and 12 added to 30 is 42, and 7 stays there, and the rest of the table does not change. So we have 18, 25, 42, and 36. Okay, now this is like the first shift. Okay, now when we move to the next digit, 36, it turns out that we want to shift the number on the right one position to the bottom. So let's write the content of the table at this point. Okay, the number in the middle is, we have 7 up here, 42 and 36. Okay, and then you see the number 25 degrees and 42 minutes, you know, it was aligned with the number on the left, but now we are going to shift it one position to be down, and the reason for that is that now the number, the next number that we are going to multiply with is one order lower. Okay, so this is now in minutes and this is in degrees, and when you multiply minutes by degrees, the result is what? The result is at least, the result is in minutes and possibly higher, but it is in minutes, all right? So that's why we put it this way. So the result of this multiplication goes here and possibly one position higher as well. So now what we are going to do is multiply 36 by 25 and then by 42. So first 36 times 25, again using a multiplication table. This is going to be equal to 900, which is equal to 15 times 60 plus 0. Okay? So that means that So the content of the middle column was 7, 42, 36. Now, the result of this multiplication goes here, starting here and possibly up. So the lower order digit is 0, so we are not adding anything to 36, but then we need to add 15 to 42, and it becomes 57. Okay, so the rest of the table does not change. So we have 18 here, 36 here, and 25 and 42. And finally, we multiply 36 and 42. The result is 1512. Sorry about this. Okay, 1512, which is equal to 25 times 60 plus 12. This means that, okay, so the correct position for this product, when you multiply, a minute by minutes, it is seconds, and this is the position for seconds. So the result will start here and possibly go up, and since it is greater than 60, it will go up, and 12 will be here, and 25 will be added to 36. Alright, so let's do that. So since this is the very last step, I will only write the middle column, okay? Just the middle column. So the content of the middle column was 7, 57, 36. Now we need to add 12 here, but then we need to add 25 to 36. So when you add 25 to 36, it is 61. That is greater than 60. That means that we need to go even one position higher. So 61 is really, to represent 61, you need two ones, right? So this is 1 and this is 160. So that means that you just put a 1 here and you add 1 over here. So this becomes 58. So therefore the final answer is 7, 58, 1, and 12. And just remember that the lowest order digit is seconds, and this is minutes, this is degrees, and this is the first elevates. And you can see that we obtained the same answer as before using this method. Now here is the third and last method of multiplication, which is called the lattice method or Glassio method. And again, using the same numbers again. So again, the numbers being 42 degrees 18 minutes multiplied by 25 degrees and 42 minutes. Okay, so to do this method, we draw a grid. So and it will be, so since each number here has 2 digits, it will be a 2 by 2 grid, or a square in this case. But in general, it can be a rectangle. The number of digits doesn't have to be equal. So we make a 2 by 2 grid like this, and we divide it into rectangles. So each square is divided by a diagonal into 2 triangles, and we place the numbers like this for 25, 42, and keep going 42 and 18. Oh, actually, I think I made a mistake. So the 2 numbers that we have are, this one is correct, but this one is incorrect. So this number is actually 18 degrees and 36 minutes. I want to use the same example to show that we obtain the same result. Oh, sorry about this. Actually, I wanted to erase this one over here. So this is 18 and 36. And this is supposed to be here 18 degrees and 36 minutes. All right. Okay, so this method will be similar to the multiplication table method, but it is organized differently, and we don't have to draw many figures. That is the advantage. So the first step is, actually what we do in this method is to go ahead and multiply all of these 4 possible combinations of numbers and fill in the spaces here. So if we start at this corner, for example, 42 and 18, for this grid, you multiply the 2 numbers involved are 42 and 18. And 42 times 18 is equal to 756, which is equal to 12 times 60 plus 36. So that means that we need to use these 2 digits, 36 and 12, in this position. Now the question is, which one goes where? Should 36 go to the lower half or upper half? Well, it should go to the lower half because in the vertical direction, the orders are going down as you go down. So 36 is the lower order digit, so it goes here, and 12 is the higher order digit, so it goes to the upper part. So next we can take any of these remaining 3 squares. Let me just take this one for example. So to fill this square, you multiply 42 and 36, and you can see that the result is 1512. And again, here you are actually using a multiplication table, right? You do need a version of multiplication table, or you do all the calculations by hand. And this 1512 is equal to 25 times 60 plus 12. And so we use 12 here and 25 here. So we can similarly go ahead and fill in all the squares, all the spaces here. So next, if we do this corner over here, so it will be 25 times 18. It is 480, which is equal to 7 times 60 plus 30. So the 2 digits that we need are 30, which is the lower digit, and 7. And finally, for this square, we need to multiply 25 and 36. It is equal to 900. It is equal to 15 times 60 plus 0. So we have 0 here and 15 here. So once we fill in all the spaces, all the triangles, we can now start adding. We are going to add all the numbers in a diagonal. So in this diagonal there is only one number, and it is just 12. In this diagonal we add 36 and 25, and it is equal to 61. So since it is greater than 60, we just put a 1 and carry a 1 over here. Just like, addition in decimal, when you are over 10, let's say if it was like 11 in decimal system, you would keep 1 here and you would carry 1 to the next position. So it is the same idea, the only difference being you carry when you go over 60. So now we add 1, 12, 30, and 15, and the result is 58. And so 58 is less than 60, so we don't carry anything to the next position. And there is only one number in this diagonal, it is 7. So therefore the final answer is 7, 58, 1, and 12. And then you can again remember that the lowest order position will be seconds, the next is minutes, degrees, and the first elevates. And again, this is the same answer as we obtained in the previous with the previous methods. Before closing this section, let me remind you that there are some typos in the book in the example for leveling. So please pay attention to that. So the typo actually comes from the very first step when he converts 4 degrees and 15 minutes to all minutes. It should be 255, not 235. So it is written as 235 in the book, and this mistake carries over to the rest of the calculations, and the final answer is incorrect. So see if you can correct this example in the book using this correct value from the first step, and see if if you can do that, you really understand this method. Okay, so give it a try.